Okay, I want to show you the two problems I asked you to do yesterday. And so this was the one that we decided to call number 3, or I decided to call number 3, because it's the third problem on the page. It only made sense. So this is what your answer should have looked like. Your vertex is over here at -3, 0, because you're left 3 and not up or down. Oh, this time I threw in a y-intercept. Did that trick you? A y-intercept is wherever the graph touches the y-axis. And the graph is touching the y-axis right there. So that's our y-intercept, which is the ordered pair 0, -4. So I threw that in, so that was something kind of new. That's the highest point, called a max. How high is it? It's 0 high. Remember, it's always the y-coordinate to the vertex that's the max or min. Okay, and then how'd you do on the rest of it? Look pretty good? Okay, and then I asked you to try the next one, number 4 here. And so this is what your number 4 answer should have looked something like. So take a moment and see how you did with this, and hopefully you're feeling really good with this lesson. Okay, pause it if you need to look at it longer. All right, so the other day we were working on this lesson, which I have posted on your Canvas calendar, so you could always click on the link and you'll see the exact same stuff that you see here. So we did the first and second page, and there's a third and a fourth page that I'm going to start looking at next. Okay, but one thing I want to make sure that you're all noticing in case you haven't noticed already. Whatever the x-coordinate of the vertex is, that's the same x value to the axis of symmetry. And hopefully that kind of makes sense to you because the vertex is on the axis of symmetry. So if the vertex is going to be on the axis of symmetry, then their x-coordinates would have to be the same. All right, so once again, I'm showing you that the x-coordinate to the vertex is the same as the x value of the axis of symmetry. I'm going to show you again. The x-coordinate of the vertex is the same as the x value of the axis of symmetry. Okay, that's really important for what I'm about to show you. All right, so the third page. We are now asked to find the axis of symmetry and the vertex and all these other things by not looking at a picture, but by looking at an equation. Okay, so we have a formula to find this axis of symmetry, and it's up here. To find the axis of symmetry, it tells you to take the opposite of b and divide by 2 times a. So remember, a is in front of the x squared, b is in front of the x, and c is the constant. Okay, so as I look at this down here, my a is a 1, because that's the number in front of the x squared. My b's a -2, because that's in front of the x. And my c's a -3, because that's the constant. All right, so the first thing I'm going to do is I'm going to find the axis of symmetry with this new formula. X equals opposite of b over 2 times a. All right, so they want us to take the opposite of our b. And what's the opposite of a -2? A +2. Then they want us to take 2 times our a. Well, our a is a 1, so what do you get if you take 2 times a? 2. 2 times 1 is 2. So I've got 2 divided by 2, and what's 2 divided by 2? 1. So our axis of symmetry is the equation x equals 1. And it is very important to put x equals, even though you may not think it's important. And I'm going to remind you why. When I go back and I look at these pictures, the axis of symmetry is a vertical line, and a vertical line is a vux. That's why it has to say x equals. See, every time we wrote axis of symmetry, it was x equals. Axis of symmetry, x equals. So every time you do axis of symmetry, you need to make sure that it says x equals. Okay, now this next thing is very important. So remember how the axis of symmetry is also the x-coordinate to the vertex? Axis of symmetry, is the x-coordinate to the vertex. Axis of symmetry is the x-coordinate to the vertex. So I know right now that the vertex has an x value of 1. So whatever you get for your axis of symmetry number, that's the x-coordinate to your vertex. So if this is a 2, this is a 2. If this is an 8, this is an 8. This is a 12, this is a 12. Okay? Are you going to be okay, Colin?
Yeah.
All right, next thing we're going to do. Sorry about that, everybody. We're going to use a little common sense here. This 1 is an x, and we're looking for the y. So if this 1 is an x, then we're going to put 1 into this x, we're going to put 1 into this x, and when we work it out, look who it's going to give us. It's going to give us the y, and that's exactly what we want here. So I'm going to write y equals, as soon as I see that x, I slap parentheses down. I'm going to put the 1 into it with the squared, minus 2. As soon as I see the x, slap parentheses down, put the 1 into that one, and recopy minus 3. And then I am just going to put this whole expression into my graphing calculator. So remember, the link to this is on your Canvas calendar. So I showed a video of how to get to it. And so today we're going to practice. So in parentheses, I've got parentheses 1 squared. So the left parenthesis is above the 8. So parenthesis 1. The right parenthesis above the 9. Close it, square it. So 1 squared. And then minus 2. So minus 2 parenthesis 1. Close it. And in the back, minus 3. Minus 3. And I'm going to hit enter. And that is my y value, -4. So right here, I'm going to write -4. And that's the y value. So that is the y value to my vertex, and I'm done. Okay, now the y-intercept, if we come up here, this is going to be fantastic. The y-intercept is the point 0, C. As long as the equation is in what's called standard form, which means there's no parentheses in the equation, and it goes highest exponent to lowest. So when we look at this equation, there's no parentheses, it goes highest exponent to lowest. So as long as it does that, the y-intercept is going to be 0, C. So that means I write 0, comma, and then who's the C? -3. All right, now we got to use our thinkers a little bit. All right, a couple things we need to know, and it's up here in the directions. If our A is bigger than 0, meaning if our A is positive, the graph opens up. If our A is smaller than 0, meaning the A is negative, the graph opens down. So let's look at this problem. Our A is a positive 1, so does the graph open up or down? The graph opens up. If a graph opens up, do we have a max or a min? We have a min because the vertex would be the lowest point of the graph. And then I'd want to know how high or how low it is. So let's go back and look at the pictures from the other lesson. Wasn't the max or min the y value of the vertex? Look, the min value, the y value of the vertex. The max value, the y value of the vertex. So whatever the y value is to the vertex, that's going to be our max or min number right here. So the min is -4. Okay, I'm going to try another one of these with you, and let's see how it goes. Now, this is a little harder than the other lesson. All right, so looking at this. First, let's identify A. Do you know who A is? It's -1. Do you know who B is? It's -4. Do you know who C is? It's +5. Okay, let's just talk about A real quick. Our A is a negative number, so does this graph open up or down? If A is a negative, the graph opens down. So if a graph opens down, do we have a max or a min? We have a max. Okay, I'll answer the rest in a little bit. All right, first thing up, axis of symmetry. Remember, it has this new formula to us. X equals opposite of B over 2 times A. So what do you get if you take the opposite of your b? What's the opposite of a negative 4? A positive 4. Then we want to take 2 times our a, and our a is negative 1. So what is 2 times negative 1? Negative 2. So I've got 4 divided by negative 2, which is negative 2. So our axis of symmetry is x equals negative 2. And remember, we need that x equals because axis of symmetries are vertical lines that split parabolas in half, and vertical lines are vuxes. Okay, if you forgot, whatever the axis of symmetry is, that's the x-coordinate to the vertex. Whatever the axis of symmetry is, that's the x-coordinate to the vertex. So that means the x-coordinate to our vertex is what? Negative 2. Whatever you get here is here. Okay? Now, common sense. If this is an x, put it in that x, put it in that x. Work it out, and you'll get Mr. Y. Okay? So let's do that. So I have to be careful with this. So I'm going to write y equals, then I write the little negative. As soon as I see the x, I slap parentheses down. Now get the negative 2 into the x, then the squared, then minus 4, slap parentheses down, get the negative 2 into that x, and recopy plus 5. Now I get to put all of that in my calculator just like I wrote it. I need that negative, and I need the parentheses with that negative. Okay, so I'm going to go to my handy dandy graphing online calculator. All right, so I've got parenthesis. No, I got the negative first. Sorry. I got that little negative. So negative, then parenthesis, negative 2, close it, square it, minus 4. So minus 4, parenthesis, negative 2. And then in the very back, plus 5. And when I hit enter, I get 9. Okay, so that is going to be my y value. So I'm going to come over here to where the y goes, and I'm going to put the 9 I found. All right, as long as an equation is in standard form, no parentheses, highest exponent to lowest, the y-intercept is always 0, comma, the c. And the c is that 5 right there. Okay, and then the max or min value. Do you remember? The max or min value is always the y-coordinate to the vertex. The max or min is always the y-coordinate to the vertex. And what did we find the y-coordinate of the vertex to be? We found it to be 9, so that guy right there is going to be a 9. Okay, so what I want you to try for me is I want you to try number 3 here. I want you to find all the things that I just found, and then I want you to take a picture of your work, and I want you to put it on Canvas so we can see how it looks and how you're doing. All right, and then you'll be done with my class for the day. So that's it. Smiley face.